Find the greatest common factor of the two numbers. In my class, we use the factor tree method to find common factors. So I can split these up based on what can multiply to make 54 and what values can get multiplied together to make 72. Six times 9 is 54, but 6 can be broken up into 3 times 2, and 9 can be broken up into 3 times 3. 72 is 9 times 8. 9 can be split into 3 times 3. 8 can be split into 2 times 4. And 4 can be split into 2 times 2. So to find common factors, I see they both have a 3. They both have a 2. They both have a 3. So I have 3 times 2 is 6, and 6 times 3 is 18. So the common factor between 54 and 72 would be 18. Rectangles A and B have whole number side lengths and are joined to form one large rectangle. The area of the large rectangle is 24x plus 36 square units. What is a possible width of rectangle A, or a possible length? Well, if we made our width 2, then the length to get A to come out to 24x, if we split it up into 2, this would be 12x. Because 2 times 12x would give us 24x. If we still use that width of 2, then the length for rectangle B, the area is supposed to be 36. So 2 times what number gives me 36? That is 2 times 18. And it says, based on your answers from part A and B, determine the width and length of the large rectangle. Well, it would still have a width of 2, and the length would be this whole part, so 12x combined with the 18. D says use your answers from part C to write an expression that represents the area of the large rectangle in square units and is different from the expression given. So we had the width times the length. And you can see if we use the distributive property like we saw in the last lesson, 2 times 12x is 24x, 2 times 18 is 36. There are other possible answers here as well. We could have made the width be 12, then 12 times 2x would give us 24x, and 12 times 3 would give us 36. So we could have also written this expression if we changed the width to 12 instead of 2. Or if we made the width be 6, 6 times 4 gives us 24, so 6 times 4x is 24x, and 6 times 6 is 36. So we could have this expression also. We're using factors of 24 and 36 as our width. Riley buys lollipops and candies to make identical treat bags. A, what is the total number of treats Riley buys, and how do you know? Well, it looks like she has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lollipops. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But there are 3 rows of 10, so 30 candies for a total of 42 treats. B. Riley makes 3 identical treat bags. Oh. He uses all the treats. How many lollipops are in each treat bag? How many candies are in each treat bag? And how do you know? So if he makes 3 identical treat bags, if we split the 12 into 3 parts, we would have 4 lollipops. And if we split the 30 candies into 3 identical bags, they would each get 10 candies. And how do we know? Well, 12 split into 3 parts is 4, and 30 split into the 3 bags would give us 10. Riley writes 3 times the sum of 4 and 10 to represent the total number of treats. What does the factor 3 represent? That is the number of bags. And what does the factor 4 plus 10 represent? That is the number of treats that goes in each bag. Is 3 times the sum of 4 plus 10 equivalent to 12 plus 30? How do you know? Well, using the distributive property, we would do 3 times 4 plus 3 times 10, which is 12 plus 30. So are they equivalent? Yes. And the way we know is by using the distributive property. Consider the treats from problem 2. Group the treats to make more than 3 identical treat bags. Use all the treats. How many bags are there? How many lollipops are in each treat bag? How many candies are in each treat bag? Well, I know that 12 and 30, if I split 12, that's 4 times 3. And 4 can be broken up into 2 times 2. 30 is 6 times 5. And 6 can be made up of 2 times 3. So these both have a 2, and they both have a 3, which is 6. So they both have a factor of 6. So we can make 6 bags. And if we make 6 bags, 12 split into 6 bags would be 2 lollipops. And if we split the 30 candies into 6 bags, 30 divided by 6 is 5 candies in each bag. Write an expression that represents the total number of treats as a product of factors. State what each factor represents. So this would be 6 times 2 plus 5. The 6 is the number of bags. And then the 2 plus 5 factor is the number of treats that goes in each bag. Use the distributive property to show that it's equivalent to 12 plus 30. So we would do 6 times 2, and then we would do 6 times 5. 6 times 2 is 12, and 6 times 5 is 30. So here we have the two different methods so far. The one where they created 3 bags, and the one where we created 6 bags. How many bags would we make if there were 6 lollipops in each bag and 15 candies in each bag? Well, 2 times 6 is 12, and 2 times 15 is 30. So in this expression, there are only 2 bags. We are going to fill in the blanks with the values that make the expression in each row equivalent. So we're thinking about 5 times what number gives us 15? 5 times 3 is 15. And 5 times what number would give us 20? 5 times 4 is 20. Here we have 7, and we need to turn it into 63. 7 times 9 is 63. Well, then using the 9 into this position, 9 times what number is 45? Well, that would be 9 times 5. What could I multiply by to get 12? If I start with 3. 3 times 4 is 12, and 4 times 1 is 4. Use the distributive property to write each sum or difference as a product. Well, I know that 9 and 36 have some common factors. That would be 3 times 3. 36 is 3 times 12. 4 times 3 makes 12, and 2 times 2 makes 4. So these have a 3 in common and a 3 in common. So they do have a common factor of 9. If I pull out the 9, 9 times what makes 9? 9 times 1. And 9 times what number gives us 36? That would be 9 times 4. In this next one, I see that 40 and 10, a common factor between 40 and 10 is 10. 40 is 10 times 4, and 10 is 10 times 1. Consider the treats from problem 2. Let P represent the cost of each lollipop in dollars, and let C represent the cost of each candy in dollars. Write an expression that represents the total cost of all of the treats. We had 12 lollipops, and each one costs P dollars. So 12 times the price of each lollipop would give us the total price for the lollipops. We had 30 candies, so 30 times the price for the candies would give us the total price of the candies. And if we want the total cost for all the treats, we need to combine the cost from the lollipops with the cost from the candies. B says, Riley writes 3 times 4P plus 10C to represent the total cost of all the treats. What does the factor 3 represent? That is still the number of bags. What does the factor 4p plus 10c represent? Well, there were 4 lollipops and 10 candies in each bag, and the p and c represent the cost of those items. So this factor is the price of the treats in each bag. Is this equivalent to the expression we wrote in part A? Well, if we distribute 3 times 4p and 3 times 10c, 3 times 4p is 12p, and 3 times 10c is 30c. So yes, it is. We used the distributive property. So that's showing those two expressions. Here we're going to look at different ways in which we can find factors of both 16 and 32. I know that they are both even, so I could take a 2 out of both of those. 16x is how many times 2? 2 times 8 makes 16. And 2 times 16 gives us 32. This one up here has a typo. 8 times 2 is 16, but 8 times 4 is 32. 4 can also go into both of those. 16 is 4 times 4, and 32 is 4 times 8. And 16 can go into both of those. 16 is 16 times 1, and 32 is 16 times 2. Here we're going to fill in the blanks. 9 times what gives us 18? 9 times 2. And 9 times what gives us 9? That would be 9 times 1. Here I have 7 and 10. What could I multiply 7 and 10 by? That would give us 35 and 50. 7 times 5 is 35, and 10 times 5 is 50. Here I ended up with 2b, and I started with 6b. 2 times what gives me 6? That would be 3. Now if I'm multiplying by 3, how would I get 21a? 3 times what makes 21? That would be 3 times 7 is 21. Choose 2 pairs of equivalent expressions from problem 8 and evaluate the expressions when a equals 3 and b equals 4. We had 18a plus 9b, and we changed that into 9 times 2a plus 1b. We are going to replace the a with the number 3 and the b with the number 4. So over here we'll do the same thing. 18 times 3. 3 times 8 is 24. 3 times 1 is 3, plus 2 more makes 54. And 9 times 4 is 36. So if I add 54 and 36 together, that would give me 90. Over here, we start with our innermost parentheses. So we have 2 times 3 is 6, and 1 times 4 is 4. Then we can add these here. 6 plus 4 is 10. And 9 times 10 is 90. But it does ask us to come up with 2 pairs, so we need to use another one. We had 21a plus 6b. Should be minus 6b. And then we had 3 times 7a minus 2b. So we're replacing a with 3 and b with 4. "21 times 3 is 63. 6 times 4 is 24. And then we need to subtract. 13 minus 4 is 9. 5 minus 2 is 3. Here I have 7 times 3 is 21. 2 times 4 is 8. 21 minus 8 is 13. And 3 times 13 is 39. Factor the expressions by using the greatest common factor and the distributive property. So the greatest common factor that can come out of 7 and 14 is 7. 7 is a factor of both. So that would be 7 times 1x, but we're going to just write a single x. And 7 times 2 is 14. In this next one, between 40 and 8, 8 goes into 40, so that is the greatest common factor. 8 times 5 would give us 40, so we need 5g. And 8 times 1h would give us 8h, but we're just going to write a single h. 13 can go into 13 and 39. 13 times 1 is 13. And 13 times 3 is 39, so we need 3a. Let's see about 42. That is 6 times 7. 6 can be broken down into 3 times 2. 18 can be broken down into 2 times 9. And 9 can be broken down into 3 times 3. They both have a 3, and they both have a 2, so the greatest common factor would be 6. 6 times 7 makes 42, and 6 times 3 makes 18. "18 is 6 times 3, and 6 can be broken down into 2 times 3. 24 is 8 times 3. 8 can be split into 4 times 2, and 4 can be split into 2 times 2. They both have a 3, and they both have a 2. So 6, is our greatest common factor for this last one here as well. 6 times 3, F would give us 18F. And 6 times 4 gives us 24. So we want 4G there. A team has 12 players. The team's coach buys 1 jersey and 1 pair of shorts for each player. Let J represent the cost of each jersey in dollars, and P represent the cost of each pair of shorts in dollars. Write an expression as a sum or difference to represent the total cost of the jerseys and pairs of shorts for the whole team. Describe what each term of the expression represents. We have 12 players, so the coach needs to buy 12 jerseys and 12 pairs of pants. $12J is the cost of the jerseys. And 12P is the cost of the shorts. Factor the expression you wrote in Part A using the greatest common factor. 12 goes into both 12J and 12P. That leaves us with a J and 1P. 12 is the number of players, and J plus P is the price of like a uniform or a set of a jersey and a pair of shorts for each player. That's all for lesson 14. Basically, we're doing the opposite of what we did yesterday by factoring rather than distributing. So we're looking for common factors or things that we could multiply together to get the values in the expression.